All right, today we're going to talk about something really cool. It's a blueprint for a totally new kind of internet. And I'm not just talking about a simple upgrade. This is a complete reimagining of our digital world from the ground up. So let's dive right in.
I mean, just think about the internet you use every single day. You're probably worried about your data getting hacked, right? Or you get super frustrated with that spinning wheel of death, buffering and just slow speeds. And let's be honest, we all have to rely on a handful of massive, centralized companies for pretty much everything. But what if, just what if, we could build something completely new from the ground up to solve all of those problems at once?
Well, the answer to that big question might just be this concept called the quantum photonic mesh. Yeah, it's a mouthful, so we'll just call it the QPM for short. And what it is this wild hybrid network for the future that's designed for security, speed, and decentralization right from its very core.
So, what is the QPM, really? At its heart, it's basically a fusion of four incredibly powerful technologies. You've got the unbreakable security that comes from quantum physics. You've got the raw, mind-bending speed of light for transferring data. Then you've got the decentralized trust of something like a blockchain. And to top it all off, the intelligence of powerful local computing at every single point in the network. It's the whole package. Okay, I know what you're thinking. That sounds incredibly complex. And you're not wrong. But trust me, we can totally understand it if we just break it down into four distinct layers. Think of it this way. Each layer is built to solve a specific, critical problem we have with the internet today. So, let's take a look at each one. So problem number one, and it's the big one, insecurity. Right? Our digital communications are just constantly under threat from eavesdroppers, from hackers, you name it. Everything from your private messages to, huge national security secrets, it all relies on encryption that, let's face it, could one day be broken.
So how does the QPM solve this? With its first layer, the quantum layer. The best way to think about it is like creating a perfect, absolutely unbreakable lock and key for every single message you send. And here's the cool part. Because it's based on the fundamental laws of quantum physics, if anyone even tries to eavesdrop or intercept the key, the very act of them looking at it changes it. So they're instantly detected. It's not just secure, it's provably secure.
And how do they actually pull this off? Well, the main technology right now is something called quantum key distribution, or QKD. It's a way to exchange those secret keys with basically perfect security, and it's feasible in the near term. Looking a bit further down the road, you've got protocols based on quantum entanglement, and that could open up a whole new world of possibilities.
All right, on to the next big problem the QPM is built to tackle. Speed, or, the lack of it. We are creating and consuming data at this absolutely insane rate, and it's causing these massive digital traffic jams. Our current infrastructure is just groaning under the weight of all that 4K streaming, those huge scientific data sets, and all the real-time communication we demand.
The answer here is this second layer, the photonic layer. Forget about old-school copper wires. This is all about using light itself to transmit data. We're talking about creating these ultra-fast data pipes that can move terabits of information every single second. It's literally like upgrading from a bumpy country road to a massive, multi-lane, light-speed superhighway. And get this isn't some far-off science fiction. The core technologies are really just super advanced versions of stuff we already use. We're talking high-bandwidth fiber optic cables for on-the-ground communication, and then free-space laser communications to connect nodes across really long distances, maybe even through space, kind of like how some satellite systems work today.
Okay, so we've covered security and speed. The third major problem is all about trust and control. So much of our internet, almost all of it, relies on these huge, centralized servers owned by just a few big companies. This creates single points of failure. If they go down, we all go down. And it forces us to just trust that these central authorities are going to act in our best interest, which, is a big ask.
So the QSPM's answer to this is the ledger layer. This is really cool. It acts like a decentralized digital notary. Imagine a notary public, but instead of one person, it's the entire network. It uses distributed ledger technology, yep, similar to a blockchain, to create a tamper-proof public record of all the transactions. There's no single person or company in control. The trust is built in and spread across the entire network. So, under the hood, this layer uses that distributed ledger technology to make sure everything is legit. It also uses smart contracts to automate agreements and tasks between all the different points on the network. And crucially, it relies on really smart, scalable consensus mechanisms. That's just a fancy way of saying it. It has ways for the whole network to agree on what's true, without grinding to a complete halt. And that brings us to the fourth and final problem. In our current world, we have to move these ginormous amounts of data from what we call the edge, from our phones, our cars, our sensors, where the data is actually created, all the way to some centralized cloud to be processed. This is super slow, it's expensive, and frankly, it creates huge privacy risks.
Now, the QPM's solution for this is, I think it's most elegant. It's the compute layer, and it completely flips the script. Instead of moving all that data to the computation, it moves the computation to the data. It's a simple idea, but it's a game changer. Every single node in this mesh is its own little supercomputer, equipped with powerful local processing.
Yeah, each node is what they call a hybrid compute pod. So it's a powerful local computer with the standard stuff like CPUs and GPUs, but maybe even small quantum coprocessors in the future. These pods run AI right on the edge to make the network smarter and more efficient. And they can use amazing techniques like federated learning, which lets them train powerful AI models together without ever having to share your raw, private data. Your data stays where it belongs, with you.
Okay, so let's recap. We've got these four amazing layers, right? The quantum layer for security, the photonic layer for speed, the ledger layer for trust, and the compute layer for intelligence. So, how do they all actually work together? What does it look like in a real-world scenario? Let's imagine two nodes on the network need to exchange some data. It's actually a pretty beautiful, seamless process. First, the quantum layer kicks in and establishes a provably secure encryption key between them. Bam, locked down. Second, the actual data, the big stuff, flows between them at light speed over the photonic layer. Third, the ledger layer makes a note of it, immutably recording the transaction's metadata, who sent what to whom and when. And finally, if any of that data needs to be analyzed or processed, the compute layer does it right there on the local node, safely and securely. It all just works in perfect harmony.
I know. This all sounds incredible. But it also sounds incredibly expensive and difficult to build, right? It sounds like science fiction. So what's the actual, realistic path to get from this amazing idea to a working reality?
What I find most compelling about this whole thing is how pragmatic it is. The people who designed this didn't just dream big and ignore the challenges. They identified all the hard problems head-on, like, hey, quantum links have distance limits, or, wow, integrating all this is going to be complex. But for every single problem, there's a practical, smart choice. Start with the QKD technology we have today. Build the complicated stuff in software first to work out the kinks. Use clever ledger designs to get the best of both speed and security. It's a plan that's actually grounded in reality.
And the roadmap to get there is so logical. It's step by step. You don't just go out and try to build a billion-dollar facility on day one. No way. You start with step one, a software prototype. You simulate the whole thing on virtual machines to make sure all the rules and protocols actually work. Then you move to a small-scale hardware prototype, maybe even using cheap little devices like a Raspberry Pi. And only then, once you've proven it works, do you start the scaling experiments with more and more nodes.
Okay, so let's zoom all the way out. Why on earth would we go to all this trouble? What's the big idea, the core philosophy behind the quantum photonic mesh? And, more importantly, what could it actually mean for our future?
Really, it all boils down to a new set of guiding principles for building networks, a new rule book. Build things in modular layers so they're easy to upgrade. Prioritize privacy by default by moving the computation to the data. Use hybrid systems that take the best of all worlds to scale up. And always figure it out in software before you start building expensive hardware. You see, this isn't just a technical blueprint. It's a set of values for how we can build a better digital world, one that's more resilient, more private, and truly decentralized. A network like this, one that's secure by the laws of physics, as fast as light itself, and intelligent at its very core, it's so much more than just a faster internet. It's a whole new digital fabric that could completely reshape our world, everything from scientific research and finance to healthcare and how we govern ourselves. And that leads us to a final really important question. If we actually build this thing, what should its very first mission be?